Yeah, hello everyone. So in this video, we are going to study activity 1.2, activity 1.3 and also about chemical equations. So in the previous video, that is the part 1, I have explained you about activity 1.1 and the first page and also the video of this activity 1.1 burning magnesium ribbon and obtaining magnesium oxide in a watch glass. This video I had also uploaded in the channel. Okay, so please do watch it. Then after that, now let us study the next topic. The next topic is about activity 1.2. So first you should remember one point, that activity in activity 1.2, this is actually in this reaction, in this activity, color changes. Okay, so in this activity 1.2, we observe 2 points. One is the color changes, and which color? Yellow color, that also I'll explain. And second one, it is also known as the precipitation reaction. Why precipitation? What is precipitation? That everything you will understand now. So activity 1.2, in activity 1.2, you are going to study 2 points. You should remember 2 points. One is the color changes, and also a precipitate will form in this reaction. So for this activity, so what are the required materials or required substances? One is, take lead nitrate solution in a test tube. So solution means, in any chemical reaction, whenever he says about solution, it means it is dissolved in the water or it is added in the water. Actually, lead nitrate will be in white color. Okay, it is actually in solid state, which is in, it is a white salt. Okay, okay, fine. So what I'll do is, I'll take some amount of lead nitrate. Okay, just imagine this activity also, the video will be uploaded. You may watch it later. Okay, fine. Now I just imagine I took a test tube and I have added uh, water in it. Then I took lead nitrate and I'll add lead nitrate salt in this test tube. Fine. So that is what he's saying. Take lead nitrate solution in a test tube. Okay. First I took lead nitrate. I'll write the formula also of lead nitrate. Okay. So in grade 9 we have studied about crisscross method, right? So now I'm not going to explain you that, but you remember the formula of lead nitrate. So lead nitrate is, the lead is actually lead 2 nitrate. So lead Pb. Okay. So Pb NO3. Okay. Nitrate 3 2. This is the chemical formula of lead nitrate. Okay, PbNO3 2 in the parenthesis. Okay, fine. Now what I am doing is, I took lead nitrate. This is the first thing, and secondly, after this, add potassium iodide solution to this. So I'll what I do is, I take one more test tube, and now again I'll add this potassium iodide. Potassium chemical symbol is K. Okay, capital K, and iodide capital I, potassium iodide. So now this potassium iodide salt, okay, it is also in white color. I will add it in another test tube. Okay, test tube number 2. Now both salts are dissolved in the water, right? Okay, so then we call it as a solution. Fine. Now what I am doing? Add potassium iodide solution to this. To which one? To first one. So we took, so plus potassium Ki. So what happens when we do this? Okay, so in this reaction, what happens is, when we add lead nitrate solution and potassium iodide solution in one common test tube or one single test tube, you will get lead Pb, lead iodide Pbi2. Okay, so this I2, PbI2, actually first, whenever you mix it, see, these two are reactants. Okay, left side I told you yesterday, reactants. When we mix these two solution, the color which forms is yellow. Okay, So that you should remember. So color changes to yellow color. Then after that, so what happens? So this lead iodide is a precipitate which will settle at the bottom of the test tube. So it is in solid state. So lead iodide is a solid state which settle at the bottom. So we call it as a precipitate. Plus, okay, so lead is, see here, lead and iodide. Done. Now what are the remaining? The remaining is potassium nitrate. So remaining I'll write here. So potassium KNO3, and this potassium nitrate will be soluble. This will be soluble in the water. It is soluble in the water. Understood? Clear? Fine. Now, so now you observe here. So what happens when lead nitrate and potassium iodide will be added, or these two solution, if you add, color changes. So which color? Yellow color. Okay. And what happens? And along with that, potassium iodide, the precipitate, which will be settled at the bottom in solid state. So this is what we observe. We observe in this activity 1.2. So activity 1.2 is which type of reaction? Precipitation reaction. And what about the color? Color also changes into yellow color. Okay, so that you should write in your observation. So what will you write? What do you observe? So what will be the answer? See, here is asking the question. He is asking a question. So the answer will be the color. The color becomes yellow because, why it becomes yellow? Because yellow yellow precipitate of lead iodide deposit on the bottom of the test tube, on the bottom of test tube. This is the answer for your observation. So what happens when lead nitrate and potassium iodide is mixed? Color becomes yellow. So color, because yellow precipitate, which is in yellow color, that lead iodide PbI2. So that is in yellow color, and that is a precipitate which deposit at the deposit at the bottom of the test tube. Okay, so whenever a precipitate form, arrow will be down. If it is gas, arrow up. Okay, understood? Fine. Now, so activity 1.2 is a precipitation reaction. So you please write the same points in your textbook as well and note down the points. Okay, fine. Now let us study about activity 1.3. So activity 1.3 is actually the exothermic reaction. Okay, so you should remember what is activity 1.3, what we are going to study. Exothermic reaction. So what is an exothermic reaction again? So in any chemical reaction, in any chemical reaction, if heat is liberated means if heat comes out of it. Okay, heat is liberated, that is called exit, right? Exit means out. So heat comes out of it, heat is liberated out, then that is the exothermic reaction. If heat absorbed, that is endothermic reaction, that we study, that also we are going to learn. Okay, so it is exothermic reaction, that is the first point, activity 1.3. And also one more point you should remember, that in this reaction temperature increases. So these 2 points you should remember for which activity? Activity 1.3. So activity 1.3 is the exothermic reaction, and also in this reaction temperature increases. So let me explain you what are the substances or materials required. First he is asking, take few zinc granules. So zinc granules are the metals. Okay, zinc is a metal, right? So in a conical flask. Now I took in a conical flask or a test tube. Even you may take in test tube also. So add dilute hydrochloric acid or sulfuric acid. So what is the formula of hydrochloric acid? I'll write here. So HCl. Okay, and sulfuric acid H2, sulfuric acid H2SO4, S capital O capital 4. Okay, so H capital and the subscript. Okay, 4. Fine. Now what is he saying? He's saying, see, this is a concentric, these two are the concentric acids. So what we need to do, we need to dilute. So there is a process. dilute. I'll give you the trick also. See, in alphabets, the first letter comes is A. Okay, acid. So just remember, A stands for acid, and after that W. So W stands for water. So what I'll do to dilute acid, acid A2W means acid should be added into the water. Okay, so A2W. So A stands for acid and W water. So acid should be added to the water, and that to how? Drop by drop and drop by drop. Okay, using the dropper, and that too by touching uh, the surface or the sides of the beaker. This is how you should add the process to add acid into the water. So acid to be added to the water, not water to acid. Okay, this trick you can remember. A alphabet A, letter A first. So acid, A stands for, then W. So A to W, it means acid to water, acid to be added into the water. This is the procedure to dilute. Now what I will do, dilute. So either you may take HCl, diluted HCl, okay, diluted hydrochloric acid or diluted sulfuric acid. Fine. Now, so first I took zinc granules, few metal zinc granules in a test tube. Okay, just let us imagine that I took in a test tube. Okay, test tube zinc granules, and then after that I'm adding slowly drop by drop dilute HCl or dilute H2SO4 sulfuric acid. Now what is he is giving the caution saying that handle the acid with care. Yeah, teacher assistance is must. Now, do you observe anything happening around the zinc granules? This video also I'll upload. Okay. So what is he asking? Do you observe anything happening around the zinc granules? Yes. Yes. What happens around the zinc granules? We observe the bubbles. Okay. So you may write down the answer for this one in your textbook. So yes, I'm writing. Okay. Bubbles seen around zinc granules. Around zinc granules. After some time, zinc granules due to why the bubble form, because the granules, because H2, what happened, hydrogen gas, H2 gas, because hydrogen gas liberated is liberated because you are adding HCl. So HCl, dilute HCl or diluted H2SO4 sulfuric acid. So in both the acids we have hydrogen in it, so hydrogen gas comes out of it and liberates. Okay, now, okay, that is the answer for this one. Okay, this question. And now after that he is saying touch the conical flask or test tube. Is there any change in temperature? Yes, yes, definitely. So what changes? You may write the answer. Yes, temperature, or it you feel warm. Okay, you feel warm. Temperature. Why we feel warm? Because temperature increases. So in any chemical reaction, if temperature increases or or heat comes out of it, what type of reaction it is? You may also remember that it is exothermic reaction. Okay, clear. So these are the answers for these two questions. Fine. Now you observe here. So what type of a question are according to CBSE board, suppose in CBSE exam, how a question can be framed or asked in this? So maybe he asked to write the balanced chemical equation for what? For lead nitrate and potassium iodide, as I have already explained. But once again, I'll write. Okay. So what first we are taking lead nitrate. So Pb, formula Pb NO3 parenthesis close NO3 2 plus potassium iodide, formula Ki gives rise to, so what happened, which color forms? Yellow color and precipitate because of potassium iodide PbI2. Okay, PbI2 and arrow down because it is a precipitate, and then the remaining potassium nitrate KNO3, which is dissolved or which is soluble in the water, KNO3. This is the chemical reaction for this activity 1.2 and then activity 1.3. Okay, so sometimes he may ask you to draw this diagram, activity 1.3, or sometimes he may give this diagram including all the parts, and he may ask you which gas is liberated in this activity. So which gas? Hydrogen gas. Or one more question can also be asked, which type of chemical reaction it is? It is a exothermic reaction. Okay, or else sometimes he may ask you what are the materials we took in this activity. So what are the materials? Zinc granules, so dilute sulfuric acid or hydrochloric acid. Now, okay, fine, so we have studied 1.3 also, activity 1.3. Now what is the remaining? He may ask you to write the chemical reaction for this chemical equation for this reaction. So what are we taking, tell me? So we are taking zinc granules, so I'll write Zn, Z capital, N small, and it is in which state? So metal, it is a solid state. Okay, plus, and what I'm adding, just let us, he's saying that sulfuric acid. So H2, what is the formula, chemical formula? H2SO4. And which type of acid, what we are doing? We are diluting it, right? So H2, S capital, O capital, 4, and it is diluted or it is dissolved in water. So whenever it is dissolved in water, we write aqueous. Okay. So what happens? So you will get zinc sulfate salt. So I'll write hydrogen gas is liberated now. So first you write plus H2. Okay. Plus H2. So, and this is gas, right? So gas means arrow up, precipitate down. So hydrogen I have written, and what is remaining? Remaining zinc, Zn and SO4. So I'll write Z capital, N small, S capital, okay, O capital, and 4. So zinc sulfate. And what about this zinc sulfate? Where it is present? It is dissolved in water. So I'll write aqueous, AQ, aqueous. And this is what about H2? It is a gas. So you may write in bracket G. So this is the chemical equation for activity 1.3. Okay. If you take HCl, you write the answer, write the equation and drop the message in the comment box. Okay, fine. Now I hope you have understood activity 1.2 and 1.3. I have uploaded activity 1.1 video as well. And tomorrow, or in the same video, the two activity videos will be uploaded in the description. Okay, fine. Now let us study, right? Let us see here. From the above three activities, what are those three activities? 1.1, 1.2, 1.3. We can say that any of the following observation help us to determine whether a chemical reaction has taken place. So in the previous three activities, 1.1, 1.2, 1.3, what is he saying? That you might have observe any change in out of these four. So change in state. So state, right? Yes, this activity, if you take, when we have added zinc, around zinc metal, gas is liberated. So state changes. Color also changed, right? In this activity 1.2, color changed to yellow. Evolution of gas. Yes, activity 1.3 is an example of evolution of gas. Which gas is coming out of it? Hydrogen gas. And change in temperature. Yeah, in the same activity, temperature is also changing. So it is an exothermic reaction. So from these three activities, so activity 1.1, 1.2, 1.3, we have seen these four changes occurred, or four changes has happened, right? Now, as we observe the changes around us, we can see that there are large variety of chemical reaction taking place around us. We will study about the various type of chemical reaction and their symbolic representation in this chapter. So now what we are going to study? We are going to study the actual, the main topic of the subject, chemical reactions, and also the representation. How do we represent the chemical reaction? Okay, so the next topic is about chemical equation. So what is the chemical equation? First, before going to study about chemical equation, first you should know the definition of, we should know the definition of chemical equation. So what is the definition of chemical equation? I'll write a written format. Okay, I'm writing the definition. A written representation. Okay, a written representation of chemical reaction. Of chemical reaction. So chemical equation. What is a chemical equation? It is a written representation of a chemical reaction. Understood? Fine. Now, after okay, let me read this paragraph. This paragraph. Activity 1.1 can be described as when a magnesium ribbon is burnt in oxygen, it gets converted into magnesium oxide. Yes, we know that. We have studied also. This description of a chemical reaction in a sentence form is quite long. Yes. So suppose if I need to describe it. So representation spelling, I have written representation SCN. Okay. So what is he saying? To describe it, we need to, I'm here, we need to write the sentence, right? It is too long. It takes some time also. So instead of that, we can write in a short form. So how? So by using the words. See, magnesium, I have written MAGNES. I have written the spelling of the magnesium plus oxygen spelling. Okay, the word, and then magnesium oxide, the product. So left side, whatever you have, they are the reactants, LHS side, left hand side, and right side product. And in between these two, you will see an arrow. This is a tail and this is head. So head is pointing towards the product and tail is pointing towards the reactants. So let me read this. The substances that undergo chemical change in this reaction 1.1, magnesium and oxygen. So these two substances are undergoing in the chemical change. So they are known as reactants. And after they both get reacted, we are getting a final product. The final substance or a new substance, and that is known as the product. So a word equation change reactants to product through an arrow placed between them. So what is he saying? What he mean to say? He mean to say that, like, in between reactants and product, there is an arrow. Okay, so arrow, the head points where? It points towards the, shows towards the product, and tail towards reactants. And now if you observe, here we are taking two reactants. We are using two reactants. So that is the reason I used plus symbol left side. So that is what? Plus sign. And right side, how many products are there? We have obtained only one product. So I am not using any plus. But if we get more than two products, then we separate the products by using plus symbol. This I have already explained yesterday also. Okay, understood now? Fine. This is what he is explaining in this paragraph. Now, writing a chemical equation. So, how to write a chemical equation? See, first one is sentence. First, he is talking about the sentence. Okay, sentence is quite long. So, after sentence, short form, writing the word equation. Again, I have written in the word equation. This is also, like, long, right? It is also long when you compare. Now, so what I do, final thing, finally, I try to make them in a very shorter method or short method by using what? Symbols. By using the symbols of a chemical equation. So here what happens? Then it becomes very small. So instead of that, I use a chemical formula symbol. So for magnesium, I will use Mg. Okay, and for oxygen is a diatomic particle. So I'll write O2 plus magnesium oxide, MgO. So this is how we write a chemical equation. So chemical equation will be written by using chemical formula instead of sentences or instead of words. Okay, so we are using chemical formula. So this is a, which one? This is activity 1.1. I have already explained in the previous video. Now observe, he is also again saying that count and compare the number of atoms on each element on the left hand side and right hand side. So now he is asking count. So count left hand side atoms. How many? Magnesium, how many atoms we have? One atom. Oxygen, how many atoms? Two atoms. Now you compare right side. Magnesium, how many atoms? One atom. What about oxygen? Oxygen also you have one. So is it balanced? No, it is not balanced. So what you need to do? You need to balance it. So how to balance? So next topic is how to balance. So first what we do is, first the word equation will be written in the form of using chemical, like chemical symbol. Okay, fine. So zinc, next activity 1.3. Okay, activity 1. Zinc plus, okay, sulfuric acid, right, H2SO4 gives rise to zinc sulfate. Okay, you write on this. Zn means zinc. Zn, zinc plus, okay, zinc plus, what is H2SO4? Sulfuric acid. Sulfuric acid gives rise to what? It gives rise to zinc sulfate. Okay, I'm writing zinc sulfate is a salt. Okay, zinc sulfate plus, and which gas is liberated? Hydrogen gas. Okay, fine. So this is a word equation actually. So word equation is representing by chemical symbols. Okay, fine. Now, if you observe in this chemical reaction, let us see whether it is balanced or not. So right side, see, first check left side zinc. Here right side, how many zincs are there? Only one zinc. So zinc is balanced. Now come to hydrogen. Left side, how many hydrogen atoms are there? Two. So right side, two. Now you see sulfur. Sulfur, how many? One left side. And what about right side? One. Now what about oxygen atoms? How many left side? Four. And how many right side? Four. Now is it balanced or not? Yes, it is balanced. So here it is given in the tabular form. So what he did is, in this table, first he has written all the elements. First element zinc, then second hydrogen, then third sulfur, okay, then fourth oxygen. These are the elements which are present in the chemical equation, right? In this chemical equation. Now, so left hand side are called reactants. So first in the second column, second box, number of atoms in reactants. LHS means left hand side. And another column, another box, number of atoms in the products are right hand side. Now what is like just you see here. So zinc, how many left hand side? One. So we have it is written one here. What about right hand side zinc? How many? One. So now you check whether it is balanced left hand side. Yes, it is balanced. Now come to the next atom, hydrogen. How many hydrogen left side? Two. How many hydrogen atoms right side? Two. Is it balanced or not? Yes, balanced. Now go for the next element, sulfur. So sulfur, how many left side? One. And right side? One only. So it is balanced. Now come to next element is oxygen is remain. So oxygen, how many oxygen left side? Four. Right side? Four. Is it balanced or not? Yeah. So this is already a balanced chemical reaction. So it is balanced now. Now coming to the, let us see the next chemical equation. So what is the next chemical equation? It is iron. Okay, iron. One more point you should remember here. Here in 2020, okay, in 2020, sorry, not 2022, I think, in 2020, in CBSE board, there is a question asked for 1 mark. Okay, I'll write the question. You try to solve the answer. The product, okay, the product formed, how the question is framed here. See, the product formed zinc reacts, when zinc reacts with sodium hydroxide. Okay, what are the product which is formed when zinc reacts with sodium hydroxide? This is a question asked for 1 mark in where? In 2022. 2022 1 mark question. Okay, or it can the question I'll write here. The question zinc Zn plus sodium hydroxide NaOH capital. Okay, gives rise to dash. And this is the question asked. Okay, so what will be the answer? Tell me. So it is already given in the textbook also. So the answer in this dash, the answer will be sodium zincate. Okay. So when zinc reacts with sodium hydroxide, so we get, I'm writing the equation here, sodium zincate, Na2, okay. Using the mouse, so handwriting is not that much clear. Okay. So sodium Na2 is Na2 sodium zincate ZnO2 Na2 ZnO2 sodium zincate will form along with that sodium hydroxide na, so hydrogen gas comes out of it. So now what is this? This is called sodium zincate. So very important chemical equation, sodium zincate plus hydrogen gas. Okay, this is asked for 1 mark, so you should remember it. Okay, sodium zincate was the formula Na2ZnO2. Okay, fine. Now let us go for the next one. Next is iron. So F is ferrum. Okay, so iron. Let us try to balance. He's asking to balance the chemical equation. What he has given: iron plus water H2O gives rise to ferric oxide Fe3O4 plus hydrogen gas. Now he is asking us to balance it. So there are two methods. Okay, there are once if you practice number of questions, now balancing the equations, then you will understand. You will also like yeah, you'll know how to balance the chemical reaction. Now, first if you observe here, so check left side. So what is the process here? He's asking. First, if you write the elements, all elements. So first one, let me write element iron left side. Okay, and next one hydrogen. Okay, and what is the next element? Oxygen. Anything extra? No, fine, done. I have written all the elements which are present in this chemical equation. Now, first left hand side reactants, left all the reactants left hand side LHS and products right hand side RHS. So these are the products. See now products here reactants are two, so we use the symbol plus to separate the reactants. Now how many products here? Two products. So again we use the symbol plus. Okay, if more number of products are there, we separate by using the symbol sign, plus sign. Okay, so Fe how many left side? One. So right side how many Fe's? Three. So is it balanced? No. First let me write all the elements, all the number of atoms which are present left side and right side. Next hydrogen how many left side? Hydrogen two. And how many hydrogen present right side? Two. So hydrogen is balanced. Now come to oxygen. How many oxygen left side? Oxygen one only. And what about how many oxygens present right side? So there are four oxygens. Now what we need to do? So now we need to balance it, right? So how do you balance? So there are so many methods, right? So if you keep on practicing here, already given step by step. Okay. So I'll directly write the final one. So first I need to see here. Here I have three iron atoms. Here I have one. So what I do, I'll keep three here. Now left hand how many? Three, right? So I'll use another color. Okay, I'll use another color. So here now left hand side three, and what about right hand side? Three. Fine. Now come to hydrogen. Hydrogen is balanced. You need not to change. Now we need to check for oxygen. We need to balance it. So we should not keep four here, right? So this is wrong. So where to keep four? So we should keep four in front of H2. So now you check once again. So left iron how many? Left hand side three, right hand side three, balance. Now what about next one hydrogen? How many hydrogen you tell me here? Here two previously, but when I put four here, it has become multiply two into four, eight. Now left hand side hydrogen are eight atoms. Now what about right hand side? Only two. So how many you need? Six we need, right? So I'll keep four here. Now you check. Two fours are eight. Now is it balanced or not? Yes, it is balanced. Now come to the oxygen. Now left side if you see four oxygen. So how many? Four. Now what about right hand side? Oxygen how many? Four. Now is it balanced or not? Yes. So what will be the final balanced chemical reaction? Chemical equation is 3Fe plus 4H2O, 4H2O, okay, 4H2O gives rise to Fe3O4, ferric oxide Fe3O4, because when iron exposed to water or moisture, it forms a layer, ferric oxide, right? Plus Fe3O4 plus 4H2. This is the final chemical equation, balanced. Now, here if you observe, is it balanced previously? No, it is not balanced. So, any unbalanced, okay, very, very important, any unbalanced chemical equation, unbalanced chemical equation is called as what? Is known as skeletal equation. Understood? An unbalanced chemical equation is known as skeletal equation. So what we have to do, we need to balance the skeletal equation. So when you balance the skeletal equation, it is called balanced chemical equation. So this is how we should balance it. So one more easy method is also there, but now it's not required. So first what you have to do, you should write all the elements. Then after that, number of atoms left hand side, number of atom right hand side, and try to balance the chemical reaction. Then you will get the final balanced chemical reaction. So here in your textbook, he has given, see, the final one. And this is the balanced chemical equation. Balanced. If it is not balanced, it is called as skeletal equation. Okay, fine, understood. So number of atoms on both sides are equal. This equation is now balanced. This method of balancing chemical equation is called hit and trail method. So which method that we have used now to balance? The method is known as hit and trail method. As we make trials to balance the equation. So we make trials, right? We're keeping 2 here, left side, right side 2, sometimes left side 4, right side 4. So these are the trials we made. So that is why we call it as a hit and trial method by using the smallest whole number coefficient. So what is the coefficient here? See, previously 3 was not there. So 3 coefficient I took here. So previously 4 was not there. So I took 4 coefficient. These are the smallest coefficient. Why? To make the chemical equation balanced. Okay, now fine. Now we have written balanced. You made it balanced equation. Skeletal equation, you made it balanced. Now what about the next topic, or what is the next procedure? You need to write the states, physical states also in the brackets. So what are the physical state? Tell me, there are 3 types of states. One is solid state, liquid state, gaseous state. Suppose if it is dissolved in water, then it is aqueous. We write aqueous also. Okay. For precipitate, arrow down. For gas, arrow up. For solid, we write in. Now so after balancing, then we need to write the physical state also. Now tell me iron. Iron is a metal, right? So will be in solid state. So I have written S here. Now what about H2O? So very, very important here. Okay, very, very important. Water is given in which state now here? Gas. Okay. So why, sir? Why actually water should be in liquid state now? Why, sir? Here it is mentioned G, because here the water H2O indicate that the reaction used, or water used in the form of steam. Very, very important. Underline. Please do underline it. So used in the form of steam. That is the reason here water is in the state of gas. So I have used gas here. So I need to mention the physical state also. It is in gaseous state. Gives rise to ferric oxide. Ferric oxide, it is also solid state. So I have put S. Now hydrogen. Hydrogen gas liberated. Na? So gas, which letter or which symbol? G. So as it is a gas, so you may put above up arrow also. So I hope you have understood. Okay, you have understood about writing chemical equation using chemical symbols. After that, how to balance. After balancing, so if it is not balanced, it is called skeletal equation. After balancing, we need to write the physical states also. Okay, fine. So, and also we need to mention the physical state by using G, L, A, Q, S, okay, and on so on. And then now you see here, sometimes, okay, sometimes, like, the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below the arrow. So sometimes in any chemical reactions, there are some conditions. There are some conditions which has to be given certain temperature, okay, which is mandatory. That time those conditions, na, we will mention above the arrow or below the arrow. So in this here, okay, I'll write here. So what are the what is happening here? You see in this chemical equation, he is taking carbon monoxide, CO. So carbon monoxide. Okay, I'll write. You also note down in your textbook. Carbon monoxide. Mono means one. Monoxide gas, right? Plus H2 means what? Hydrogen gas. Okay, gives rise to what happens when you add carbon monoxide and hydrogen gas. Okay, carbon monoxide gas. So what will you get? You will get methyl alcohol or ethanol. Okay, so we will get methyl alcohol. So now methyl alcohol, which state? Tell me. Liquid state, right? So what happens here? Very, very important. This is very important chemical reaction. See here, carbon monoxide. We are using both reactants gas. But what is the final product? We should get gas only, right? But here we are getting liquid. How the liquid? Only one condition, when you provide or when you give 340 atmospheric pressure. So this is condition. So when 340 atmospheric pressure is being given in this chemical equation, you will get ethyl alcohol in liquid state or liquid form. So this is also one important equation. So this is a condition. Only here you are taking two gases, but product is in liquid state. So that time you need to mention it above the arrow. Next one, if you observe here, another chemical equation, that is carbon dioxide plus water. Carbon dioxide, which carbon dioxide actually it should be gas, right? But it is dissolved. Okay, so aqueous state plus water liquid state. In the presence of sunlight, and chlorophyll, so what do we get? Glucose, C6H12O6, aqueous state, plus oxygen plus water. Okay, oxygen aqueous dissolved state, and water liquid state. So this is all. So see, here we are taking carbon dioxide and water. So what are we getting? We are getting glucose. So this is a photosynthesis process. So plants prepare their food in the presence of sunlight. So sunlight is mandatory. So that is it, mandatory. So it is written above the arrow. Okay, so for some chemical equations, the conditions are must. So that time we write above the arrow or below the arrow. Okay, so I hope you understood till here. Any doubts if you have, just comment in the comment box. And now, the next topic I'll record in another video. Thank you so much.